is Anusha. In this video, I am exploring how to handle dates data in SQL. So, date handling allows you to track, filter and analyze time-based data accurately, enabling insights like trends, durations and seasonal patterns. In databases and DBMS, it ensures consistency, supports scheduling, reporting and enables precise aggregations across different time zones. In this video, my objective is to discuss briefly about date data types, basic date functions, about date formatting, date arithmetic, and finally we'll demonstrate all the topics using TRIPS data. So coming to date data types, the standard form of dates is year, month and day, and we use date time and timestamp when we need both date and time. And then for large data sets, indexing date columns is a good practice to optimize queries by date ranges. So coming to date data types, here I have a table, events table, where I have these columns and their respective data type. So here you can see plan mid is timestamp, where timestamp means we have the date as well as time. And the event date I have given only date because we only need date. Event time I have given only time data type, so it's only time recorded. And created at, we have used date time data type, where date and time both are stored. So these are some data types by which date kind of data is stored. So coming to some basic date functions, this is current date function which will give you current date, current time function will give you current time, and now function will give you the date as well as time. And you can extract parts of the date or time with these functions as well. And coming to date format, like how we want to display the date. So we know the default format is year, month and day, but here we are changing the format using date format function as day, month and year, and H is the hour, I is the minute and S is the second. And in the same way here, there is a function called day name which will give the day name of the date passed. And here we have in date format, if we give percentage capital W, we'll get full weekday day, and percentage A we get short weekday name, and in the same way percentage M for full month name and percentage B for the short month name. Coming to date arithmetic, so we have two functions widely used, that is date add and date sum. Here date add with interval 7, it will add the interval with the date given, and it is how we have added 4 and interval 7, that is 11. In the same way for date sub also we can subtract in intervals. So here we are subtracting 2 days. It's a day interval. If we want to add or subtract, then here you can pass like here interval 1 month is added, here interval 2 years is subtracted. In the same way we have another function called date difference which will give difference of 2 dates. So here when we pass 2 days, it is given difference in days because it's date difference. And here also we have given 2 dates, so it has given the difference in days. If we want the difference in timestamps, maybe they are from the same day, so that is when we can use timestamp difference with hour. So this date and this date, and it is 5th October 12 and 4th October 8, that is 28 hours. So now whatever date arithmetic we have seen, we will try to demonstrate them using the trip data I have, which has pickup date, drop off date, distance, fare and the payment mode. So here when we calculate the common statistics, here we have used day name function from pickup date to get the day names and their total trips, total fare and average fare. And coming to the daily trends, so here the daily trends, I simply use the date function of pickup date so that I'll get only date, not the time. And with that only I have grouped the data with trip date, and this is the whole month's data. Here I have given the dates in between 1 to 30th June. And here for daily trends, the same data, Since there are many average fare, I wanted to look at the dates where average fare is above 20. So here I have given after grouping about the trip dates, I have given the having function. So greater than 20, I am getting this value. So 7th June and 21st June are having the highest average fare compared to other days. 7th June and 21st June both are Saturdays. So maybe Saturdays the average fare is high. Coming to cumulative revenue trends, here I have used Windows function sum of fare over order by date, and this is the daily revenue and this is the cumulative revenue. I have filtered the data for 5th June to 15th June. Coming to weekly trends, so we have a function called week. So here week number will give it is the data I am using is the month data. So here you can see these are the dates in which we want the weeks. So these are the week numbers, the total trips, total revenue and average fare. And you can see that for the first week, total trips are less but the average fare is more. So it is suggesting that the quality of trips is more. And here this same query, I tried to write it by showing a week start also. So for that I have used this function, the pickup date minus interval of weekday of the pickup date. Here what it does is whatever date is picked, it will convert that interval to the nearest Monday, and then that week start is also given for intuitively understanding which week we are talking about. Then coming to weekday trends. So here we have previously also used this name of pickup date or week date and we got these values, but these are like Monday, Wednesday, Tuesday, they are sorted alphabetically, but I wanted to see all days consecutively. So here I did order by field weekday, Monday, Tuesday, Wednesday, so on. So now we can see the days properly like a calendar. So here when you check the statistics, Saturday, in spite of having low trips compared to any other day, its average fare is high compared to all the other days, and the average distance is also high, so it might suggest long trips, and also fare per mile is decent enough. Coming to trip duration, I decided to add a trip duration column. So here I have added a column. So I have tried with date diff, but then trip duration will be in the same day. So I want the trip duration in hours or minutes. So I have selected the minutes. So I have used this query, update trip set trip duration as staff difference minute, to so that we will get the trip duration in minutes. In the same way, pickup hour, I have added another column called pickup hour. So here for pickup hour, I have directly picked the hour of pickup date, and this is my pickup hours. So from 0 to 23, all the hours have come, and these are the total trips and these are the average fare. BC hours of the day. So what I did is for each day I have ranked three rank hours, so three top hours where the total number of trips are highest. So here what I did, rank or partition by day name, order by the count of trips. So with respect to the total of trips, it has ranked top 3 hours for each day. And creating pickup hour buckets, though we have so many pickup hours, if we create bucket, it's much more intuitive. So I have created buckets in this way, and when I check the average fare 10 p.m. to 2 a.m., that is very late night, the average fare is 22 and the trips are also 4058, and here the most of the trips are at 12 to 3 p.m., that is afternoon, and 4 to 6 p.m. also more trips are there. But when it comes to 2 to 5 a.m., that is almost early hours or very early morning, the average fare is more. Though the trip number is less, the average fare is more. So it might be airport trips or trips which get more paid. So here earning per mile. Since I have distance as well as the fare, I have calculated the average fare per mile with respect to each hour. Here earning per mile, again I have displayed with respect to weekdays what is the earning per mile. And I have here categorized the data into weekend and weekday using this weekday function. In 5 or 6 will be weekend or else it's weekday. So we can see weekend total trips and average fare, weekday total trips and average fare. That's all for the date handling function. Thank you.